Quarried stone and gravels, referred to as aggregates, are used in almost all aspects of roadway and structure construction. Good quality materials are needed to ensure that construction projects will provide lasting performance. Since these projects are composed largely of aggregates, proper inspection of these materials is essential. The inspection of aggregate consists of proper sampling, testing, and handling of these materials. The purpose of this program is to introduce you to the procedures used in the manufacture of coarse and fine aggregates. Our intent is to assist new technicians in their job performance as well as to acquaint experienced personnel with proper inspection procedures. We will be viewing the typical production of coarse aggregates from quarry wall to stockpile, covering proper quarry inspection as well as the recommended procedure to obtain a good representative sample. We'll also take a look at proper stockpile procedures, as well as how to remove this material from the stockpile to minimize segregation. We'll introduce the procedures common in source inspection and sampling. Sampling procedures for aggregate at paving projects, ready-mix, and asphalt plants are similar with only slight variations between the methods. Quarry inspection starts with proper ledge control. The aggregate must meet the quality requirements for each specific project. The quality of the material in each ledge is established by the historical records obtained from previous production or from a source with similar aggregate properties. This information can be obtained from the T203 or from the Materials Office of the Iowa DOT. Quarry logs are on file at the Materials Office, which give a brief description of the type and thickness of material present at most quarry locations. Once the appropriate bed numbers are determined, the beds should be identified in the quarry face. Marker beds are sometimes used to identify the different beds in the quarry wall. These marker beds are usually chert seams or shale seams that run throughout the wall. Care should be taken if dipping beds, faults, or clay and mud pockets are present. Once the desired beds are located, the beds above may need to be removed. The working ledge will be drilled to the desired depth. Be sure the material is not drilled and blasted to more than the approved depth, as material from below the ledge may not meet specifications. The drill pattern and hole location is important to produce a good, workable shot. The drill holes are loaded with dynamite, or sometimes alternative explosive, and wired. The quarry ledge is shot to prepare it for production. The technicians must visually inspect the downed shot for any objectionable material. This material must be removed prior to production. Production begins with the material loaded into a primary crusher. The material is reduced in size and moved to a surge bin to ensure constant flow to the secondary crusher or screening plant. The material then leaves the screen plant to separate bins or stockpiles. The material is stockpiled by truck, loader, or by conveyor belt. Fine aggregate may be produced from material located in a dry pit or by dredge in a wet pit. In dry pit operations, the fine aggregate is usually removed from the pit by a loader. Overburden is removed by excavation. This material is run through a screening plant or classifier to be properly sized and cleaned. Oversized material is screened off, and the finished product is placed in a stockpile, usually by a conveyor belt. In wet pit operations, the material is removed from the pit by means of a dredge or drag line. The sand is then pumped to a classifier and sent to the stockpile. An important part of an aggregate technician's duties is to visually inspect all aspects of the production process. This not only includes the quarry ledges and crushing operation, but also the stockpiling procedure. Care should be taken to ensure the stockpiles are created and maintained properly. Stockpiles should be identified to avoid confusion. Driving on stockpiles should be held to a minimum, as this could cause degradation of the material. Degradation is the breakdown of the material. If ramp areas are present in a stockpile, this material should not be incorporated in the finished project. Mingling of stockpiles should be avoided, as this procedure could contaminate the product with non-complying material. Deleterious materials such as mud, clay, dirt, or other foreign material should not be allowed in the stockpile. Be sure loaders and truck bodies are clean and free of these materials when building stockpiles by these methods. A common practice is to create stockpiles using conveyor belts. This method has proven to be cost-effective for the producer, cutting down on manpower and equipment. If done properly, conveyors can produce a good stockpile. However, care should be taken to prevent segregation of the material. Segregation is the separation of coarse and fine aggregate. Coarse material tends to roll to the outside of the stockpile, while finer material is retained in the center of the stockpile. Segregation can be reduced with proper conveyor operation. Starting the pile in lower lifts and gradually raising the conveyor while moving it horizontally can minimize segregation. Radial stackers have proven to produce uniform stockpiles and to reduce segregation. Segregation can be corrected by proper loading practices when removing material from the stockpile. Loaders should not scrape the quarry floor when loading material, but should raise the bucket slightly when entering the pile and continue raising the bucket throughout the stockpile. Material should be loaded from the stockpile at a 90-degree angle to the conveyor belt, working the entire stockpile from side to side. This procedure also aids in blending segregated material. No single phase of an aggregate inspector's duties is as important as obtaining a representative sample. Samples should be taken at the proper frequency, meet the minimum sample size, and be randomly obtained. The first step in obtaining a representative sample is to identify the material to be sampled and the correct way to obtain the sample. If you are not able to determine the correct procedure, contact your materials office for recommendations. Proper equipment is needed to take a good sample. They include a sample catching device, a belt template that conforms to the contour of the belt, a shovel or sand probe, and clean containers to hold the sample. The 3 approved methods to obtain a representative sample are the interception of the stream flow of material, belt sampling with the use of a template, and stockpile sampling with a shovel or probe. This method is the easiest to perform and often is the most reliable to ensure a representative sample. It is most commonly used in production plants. Don't take your sample at the very beginning of production or when the plant is shutting down. The sample should be taken when the plant is running at normal production. If a surge bin is used, make sure it is full to assure a constant flow of material into the crushing or screening plant. Locate the recommended sampling area, being sure it is in a safe location with safety rails and guards in place. Using your sample catcher, swing the device through the entire stream of material, being sure to get the complete flow. Pass the catcher through the material quickly to avoid overflowing the device. If this should occur, discard the increment and obtain another increment. Continue this procedure a minimum of 3 times. More increments may be needed to reach the minimum sample size. The minimum sample size for the sample can be found in Instructional Memorandum IM 301. The more time spent between increments will result in a more representative sample. Common errors in stream flow sampling include not cutting through the entire flow of material, passing the sample catcher too slowly through the stream, and not getting the catcher deep enough into the stream. If this occurs, discard the increment and obtain a good pass. Some production plants have devised their own methods to intercept the stream flow of material. This usually consists of a catching device on a slide or rollers. These devices slide through the stream and work quite well. If you encounter problems locating a good safe area to take a sample, consult your materials office for direction. The belt template method is most common in paving, ready-mix, and asphalt operations, and is usually the hardest to perform. Difficulty arises in finding a good location to get a sample. The belt is to be equipped with a shut-off switch at the sample location to be operated by the sampler. With the belt at full capacity, stop the belt and with a template that conforms to the shape of the belt, place it down on the belt, being sure to cut the entire depth of material. Clean out all the material from the belt within the template and place it in the sample container. Remove the template and start the belt to run more material through the plant. Stop the belt again to take another increment. Continue this procedure a minimum of 3 times. More increments may be needed to reach the minimum sample size recommended. Running more material on the belt will give a more representative sample. Common errors are not having a template that conforms to the shape of the belt, not cleaning all the material from the template, or not allowing enough time between increments. When wet material is clumped and not riding uniformly on the belt, try to find a location along the conveyor train where the material evens out to take your sample. Stockpile sampling can only be used for fine aggregate material. This method can be done without interrupting the production process. Even fine aggregate material tends to segregate when stockpiled, so sample the stockpile from 1/2 to 2/3 of the way up the pile. With a square-nosed shovel, cut a vertical face in the stockpile. Scrape the vertical face with the shovel to a depth of 1 to 2 inches and place the sampled material in a clean container. Move to another location around the stockpile and take another increment. Continue to sample in this method at least 3 times. Avoid sampling under the conveyor belt because this area usually contains fines. More increments may be necessary to get the minimum sample size. When using a sample probe, sample in the same manner, making sure to cut a vertical face with the probe and insert the probe at 90 degrees to the face of the pile. Wipe excess material from the probe before placing it into the container. Errors occur when a vertical face is not created prior to sampling, or when sampling from the bottom of the pile. After your sample is taken and you are sure that you have done everything to ensure it is representative, you are ready to test the material. Note all important information necessary to document your sample. This information includes the type of material, bed numbers if from a quarry, date sampled, sample location, aggregate size, as well as any special production methods used. It's an important job to ensure compliance with specifications and maintain proper quality control. A combination of proper sampling and testing, as well as good visual inspection of procedures and the production ledge, are needed to ensure we are producing materials that will last and give us a good performance for many years. Following these guidelines will bring consistency in our sampling. You were shown examples of typical production procedures as well as recommended sampling techniques. You will encounter a variety of different production methods in the field. When proper inspection is practiced, you will be sure of getting a good product. Remember, if your sample is not representative, it's not worth the effort put into getting it. For additional information on sampling procedures for these operations, contact your district materials office.